Well, good morning, good afternoon, or good evening, depending on where you are in this world. Thanks for joining us today on the DevOps.com webinar. Today's webinar is titled Applying AI to Root Cause Analysis, and it's sponsored by Loom Systems. I'm your moderator for the event, Charlene O'Hanlon, and I'm really excited about this webinar. We've got some really cool stuff coming up. But before we do jump into it, we do have a couple housekeeping items. First of all, this webinar is being recorded, so about 24 hours after today, you should be able to view the webinar on demand on the DevOps.com website. You'll also be receiving a link via email to the webinar, so you can go back and watch it whenever you want. Also, we will be taking questions at the end of the webinar, so if you have a question for today's speaker, please feel free to submit your question at any time during the webinar. And like I said, we'll be taking the questions before we close out the webinar today. So our speaker today is Dror Mann. He is the co-founder and vice president of product at Loom Systems. Dror previously was the head of product at Voyager Analytics, and he's got about 10 years or so of experience with product and project management consulting. And that's with a couple of, on multiple projects with some top Israeli companies, including IAI, which is the Israel aerospace industry, Matrix, and the IDF on the implementation of big data analytics and intelligence projects. Dror's, like I said before, co-founder of Loom Systems, and he leads the product management team there. Now, if you're wondering about Loom Systems, Loom is an AI-powered log analysis solution that gives a heads up when there may be a problem within a digital system. So it sounds really interesting. Loom connects a business's digital assets, which continually monitors and learns about them by reading their logs into text when something is likely to deviate from the norm. When that happens, Loom sends out an alert and recommended solution, so DevOps and IT managers can proactively attend to the issue before anything happens or goes down. This not only keeps the operations running smoothly and improves business productivity, it also alleviates the tedium of reading logs and frees time for operations to concentrate on other important IT matters. That's some nifty stuff there. So Dror, welcome to the webinar. Thanks for joining me today.
Thank you, Charlene, and thank you for the rest of the DevOps.com team for hosting us today. It's a really exciting opportunity for us, and it's going to be great.
Great. Well, I'm going to just turn the microphone over to you and let you do your thing.
Super. So hi, everyone, and thanks for being here today and postponing the lunch for us. My name is Dror Mann. I'm leading product development at Loom Systems. As you can see in the photo, popping out from my backpack was my focus for the last 3 years. So basically, family and root cause analysis is what I do for a living. A few words about my background. Before Loom, I was the head of the product at Voyager Labs, where we build social network analysis platform to extract insights from social media. We dealt a lot with graph databases, big data technologies, and all sorts of fun stuff. And back in the days, I was basically a data nerd, like all of us in Loom. We came from a background of intelligence, and we've been developing technologies that allow us to distill insights from big data, especially in places where there's not enough manpower. That was always our goal, including today, where we focus on harnessing technology for the sake of intelligence rather than for information. So today we're going to look on the world through these intelligence glasses. So through the agenda, we're going to talk about the digital era and the new DevOps challenges. Then we'll discuss how root cause analysis is being done today, and then see what can we expect from AI in this domain. Last, we're going to have a live demo to see AI in action, and I'm going to leave enough time for Q&A and also some polls along the way. So stay tuned and let's get going. So let's talk about the reality today. And as we all know, in today's digital era, most businesses are digital or in a digital transformation. That means that a physical business has been replaced by systems, which means more work for us as DevOps people. Now, people see applications or websites and think, how simple are they? But we all know that things that look very nice and simple are the hardest to do. In fact, there's so much complexity and technologies under the hood that make these things look simple. So in the new reality, developers are faster and more agile, but the burden has been shifted to operations. This means that managing and monitoring is the new weakest link. It's not possible to prevent failures, only to detect and resolve as fast as possible. And that human expertise is being forced to become more specialized at the expense of breadth, yet multi-layered problems are the new norm. So in the last 2 years at Loom, we've been observing dozens of DevOps engineers and SREs and production engineers to learn how do they perform root cause analysis. And we found there are actually patterns and conventions in the way they work. It appears there's a process that can be described as follows. A, detecting there's a problem. B, analyzing where and what is the root cause of the problem. C, researching and understanding how to fix it. And D, applying the relevant fix. It may sound simple, but we're going to drill down into each of these phases and see some examples in real life. So the first phase, the detection phase, it all starts when an issue was detected, and I can know about it either from my help desk or my boss who met me in the hallway and asked me some questions, or the end users are complaining that something isn't working within my web app. The other option is that I'm using one of the many an infrastructure monitoring tool, and I see that my spouse rate has some overload, which requires my attention. You see it here. Now, it's a good indication for me to drill down deeper. Guys, can you hear me? Sorry for dropping. I got some.
Yeah, we can hear you. Yeah, we dropped a packet
Thanks.
or two. It's all good.
Super. I'll try to speak a little bit slowly then. So detecting an issue by an infrastructure monitoring tool is a good indication that something is happening. However, the problem with metrics is that they only tell you part of the story. I like to think of them as symptoms that tell me I need to visit the doctor. However, in order to diagnose the issue, I need to look on the logs, right? The logs contain a richer source of information. There's a truth in there that doesn't exist in metrics. So the next step will be for me to figure out what my logs are saying during this time frame. So we're actually moving from the detection phase to the analysis phase. And the analysis phase can actually be divided into two parts. First, identifying where the problem is, and then figuring out what's the root cause of that issue. And I listed here the most common methods of identification and analysis as I see them. There's searching for bad keywords method. There's using hunch-based hints to start with, and I'm going to talk about that in a second. There's looking for weird phenomena in the data, and correlation as a really important part of the root cause analysis. And let's see some of these examples. Right, analysis. So here's an example if I don't have any log management tool in place, and I need to search manually for errors. That's what usually people do. So if I don't have anything, I'll do a remote connected server, and I'll do several grabs to see if there's something suspicious. I'm going to look for errors, for fatal, for exception, for bad keywords, more or less. If I do have a log management tool in place, like in this example, I use the OK stack, so and Kibana as the user interface of it. So I'll probably look for the same kind of different way of asking the same questions. And you can see example when I'm asking some keywords here in the search bar. And I will probably look for fatal or critical. I will read through the answers, review them, and try to see if I can find an error that explains the issue. One of the challenges of this approach is that distinguishing between errors which are normal and errors which are abnormal. So we all know that every production environment has some errors in its logs, and it's fine. So the goal is here to look for the anomalies, the things that not necessarily part of the routine behavior of my data. In this case, I have around 5,490 hits, so it's not so efficient. So I had to do some slicing and dicing in order to find the root cause. So that's the search for errors part. The other type of method is, I call it hunch-based or contextual searches. So as experienced DevOps engineers, we usually have a hunch towards what's happening, right? It can be that I know that our databases or queues tend to have problems because that's the way it is in our company. Or so therefore, I always start looking there, or any other proprietary business context you may have. So for instance, contextual information can be names of problematic components in which I will use to search for errors within these components. Or another example of context is time-based events. Like if I know that there was a configuration change this morning, I should search for conf issues, like I did in the example here. But no results has been found, so I'll have to look in other places in order to continue moving. Third and really important convention of analysis is what we've been observed, and we call it as the weird phenomena convention. This is more of a data-driven approach where the user looks for different types of weird behaviors in the data. In this example, a spike in the overall volume, which can guide me into the problematic log line. And we actually, by introducing Splunk like around 10 years ago or something, we got familiar with this type of bars visualization. It's very helpful for detecting spikes in the data. And this is one of what I call the weird phenomena. This is one type of it. The other type of it is actually more manual, and we see it quite often. Many DevOps engineers connect to a given server, entailing a given log, and actually browsing these logs rapidly to look for places where the logs look different. Now, these places are usually a potential good place to start digging because the textual structure of them just looks weird. So I'm sure you're familiar when you're doing a tail and then page up, and you're looking for something that looks strange, then you focus all your attention around that area. Now, we're going to talk about how AI can help us do the same procedures by using machines rather than humans, right? So it's important to remember that. And last but not least, maybe the hardest thing to do in complex environments is correlations. This means figuring out what else went wrong in a given time window outside the scope of one application or server. So the convention usually involves extracting an interesting entity from the log, like an IP address, or a username or ID of some kind, and search for this entity in other applications. It can take time if you have separate indexes, or in environments with very high logging rates. It's very hard to do, but it's a crucial step in the analysis phase. And you can see me here taking this IP address and going from one server to searching for this IP all across the system, and then narrowing my results based on the specific time window, which is problematic, to see what else went wrong at the same time. So that's about the analysis phase. The other part is the next phase is the research phase. So by following one of these methods, the aforementioned method, chances are that you already have found some log lines which reflect the root cause. And if you figure out what do they mean, you will be able to fix the issue. However, it's important to say that there are many other things that can be done as part of the log analysis process, which I didn't talk about them. But I feel that these phases give you a good overview of the steps involved. So for the research part, every time there are some log lines which are suspected to reflect the root cause, there are actually two things you can do with these log lines. Either these are from third-party applications, and you can Google them, or these logs come from your homegrown apps, which means you need to consult with your developers, or if you have good documentation, read it, and hopefully you'll figure out what to do. That's usually what users are doing. And the last, sorry, about the research part, I know nothing is big here, but no big news here, but it's important for me to emphasize how hard it can be. For instance, Microsoft event logs are in many cases too generic, and you'll have to scan different forums and hope that a previous user has reported your specific use case in the past and read through it. It's a very tedious process. And the same goes for open source projects. If you're using your product where the conversation is long and the answers can be hidden in one of the pages, and so on and so forth. So that's for the research part. We talked about the three main phases of root cause analysis, each with its own conventions and approaches. The last phase is about actually fixing the issue, right? Whether by escalating to level 3 or level 4 support or patch it yourself. We're not going to focus on this phase today, since it's not about finding the root cause, it's more about how to fix it, which is a different issue. However, as is today, the root cause analysis process is very manual and dependent on the human being. And with that in mind, I'd like to conclude the first chapter of this webinar, and I wanted to discuss with you the second part, which is more about machines and how can we use them in our daily jobs. So before we continue, we'll do a quick pause here and present you with a poll question.
Excellent. Thank you very much, Dror. I'm going to go ahead and pull up this first polling question. I hope everybody's been paying attention, although it's not really like a it's not really like a test. It's just a poll question. So here's our first polling question. Which of the following phases in the process of root cause analysis do you find the most challenging in your organization? So you can see the 4 answers here. You can select one of the following. Detection, knowing issues before they affect the business. Correlation, correlating between different issues. Analysis, identifying the root cause of an issue. Or research, understanding how to fix an issue fast. So we'll give you guys a couple more seconds to log in your answer, and then we'll take a look at the poll results. Oh, some interesting results coming in so far. We are almost there. Just a couple more seconds. If you haven't voted yet, please, now's the time. Okay, we're going to go ahead and close it out right now. Okay, sharing the results here. Really fascinating, actually. The results, looks like we're dead even with detection and correlation, followed closely by analysis. Dror, what do you think about these results? Do they kind of mirror what you've seen out there?
It's actually quite interesting, since, well, we're talking with many medium to large US enterprises, and they all share the same observation, as they have problems all across the root cause analysis chain. That's why it's so hard to distinguish between each part, and it actually reflects well the results we're seeing here. Since detection is always a problem, knowing issues before they affect the business, that's the hardest thing to do, because everyone's using monitoring systems to detect things, but it's always a bit too late. Mm-hmm. Correlation is always hard, and we're going to show you some cool things that we can do with that. And well, analysis, that's the holy grail, right?
Right.
So these are good results, and we were happy to see that it spread pretty much evenly. I was surprised by the research part, and I'm seeing that most of the users have decent knowledge about their log lines and what do they mean. That's great. Maybe you have great documentation, which is also great. We're going to show you how can we help you with that part as well over the next few minutes.
Excellent. Just to let the audience know that we are going to be tweeting out these poll results as well. So if you want to take a look at the results later on, again, we will have them on our Twitter feed. And also to remind the audience that if you have a question for Dror at any time, please feel free to send in your questions, and we'll be taking the questions at the end of the presentation.
Super. So thank guys for sharing your insights with us. Let's move forward and let's ask ourselves, what if there's a better way to harness technology for the root cause analysis process? Because I think that's kind of what we're trying to do today, right? So as of today, humans are better at top-down or open-ended questions. I'll give you an example. Where should I open my next branch? It's an open-ended question, right? And there's a big but here. They don't scale, and they're also hungry, married, get tired, and so on and so forth, because they're human beings, right? Now, on the other hand, machines are superior in rigorous and exhausting tasks, such as keep track on our sales in every state, slice by affiliates, let me know if something happens, right? So they're good at pattern recognition, and following a strict methodology, and usually in places where there's large dimensionality. Now, we wanted to build software that takes advantage of both these worlds. And let's let's envision together a product that would empower me to do, or empower us, sorry, to do much more than what I'm used to doing today. How can AI and machine learning can be part of all stages of the root cause analysis process? What capabilities are a must for that kind of tool? So I'm going to help you with that. First, we need to collect the data and pre-process it. So break it down to meaningful components. Anyone who uses ELK or Splunk or any other log management tool knows that the parsing and configuration takes time and patience. So to be honest, my friend that works as a data scientist in a very famous company told me that 85% of his job is about data cleansing and data preparation, and only 15% of data science. And I think it reflects well the challenges of log analysis today. So that's the first part, collection and parsing. The second capabilities we need is the ability to learn our unique data baseline and to alert about things that are likely to deviate from the norm. This will help us complement the traditional way of detecting issues. Instead of waiting for our users to complain or to define every type of threshold exists there, the AI will be able to detect deviations automatically. Now, after something has been detected, you want the tool to look for correlations, which means other things that happen at the same time, and to isolate the cause that might be accountable for the incident, right? And that's the analysis phase. And lastly, what you want is, we would need some help with the research part, although you feel quite okay with that, which means translating the problematic log lines into plain English. And if possible, also, I would like to tell me what actions should I take to remediate the issue, right? That's I think, to me, that's my dream as a good AI-based solution to help me with the root cause analysis process. So before moving forward, I like to get skepticism out of the way, because we're all a bit cynical and a bit skeptic about these type of capabilities, right? So I want to ask you, who here believes that self-driving cars will be successful after seeing Total Recall movie, the first version of it, in 1990? And surprisingly, whoever saw it, this book was released 50 years ago. And indeed, science fiction sometimes takes too long to become reality. But if artificial intelligence is mature enough to drive your car, it can probably also help with your IT, right? And in fact, we've been working very, very hard in the last 2 years to bring this into reality. And what you're about to see is already deployed in dozens of customers worldwide. Now I'm going to show you examples of the products, and I'm going to highlight the capabilities we've just discussed. So I'm going to share my browser with you. Actually, it's a good time, I think, before sharing my browser with you, to have the second poll coming.
Yeah,
Charlene.
sure. We can do the other polling question. This is the second of 2 polling questions during this webinar. So please, audience, we love to have your participation. And here is the polling question here. What is or would be the main purpose of implementing an AI-powered log analysis solution? So again, you can see there are 5 answers here you can select from: auto parsing and data preparation, cross-applicative correlation engine, proactive detection of issues, integrated knowledge base mechanism, or other. So we'll give you guys a couple more seconds to put your vote in. Some really interesting responses so far. I think you guys will be really surprised when you see the responses here. We are going to give you guys about 5 more seconds, and then we'll go ahead and close it out. And okay, okay. And we're closing it now. Okay, great. So here are the results here. The main purpose of implementing an AI-powered log analysis solution. Looks like proactive detection of issues is the big winner here, Dror, 68%. That would actually be my first answer as well. Is this something that jives again with what you're seeing and what you're hearing?
Indeed. This is actually correlating well with the previous poll as well. So you're consistent. That's great. I think that's exactly where the world should go to, and we all try to avoid these issues. As we said before, things are breaking, and that's great. And I think that's one of the things that we can help you with. And I think that I see that most of the users also feel okay with the parsing part, which also means that you're more experienced engineers than their usual people that we see, because some of the organizations that we're facing actually struggle there, and it makes their life very hard to look on stagnant data sources. But anyway, I think these results reflect well that you are in a good company and you want to get really much better than what you have today. And we're going to see some examples of how we do that in following seconds.
Great. Well, just again to remind the audience that we are tweeting out these results. So feel free to check our Twitter feed. And then also, again, if you have questions for Dror, we will be getting to them near the end of the presentation. But don't wait to get your questions in. Back to you, Dror.
So I think at this stage, I think you should see our system, the user interface of Loom. Charlene, can you confirm that?
Yep, I can see it. I can see it.
Cool. So welcome to Loom, guys. We're going to take you some several examples, and I'm going to start by not talking about the main system screen and the alerts you're seeing here, but actually talking about what's the way to start using the software. And everything starts with, if you remember, by collecting your data and make sure the software can really ingest it. So the first part is shipping your data, and the system actually can ingest any type of machine-generated input. It can be logs or metrics from your servers, whether you're using a Linux server or Windows server, and also can be databases or through an API, sending us events through the API, or if you will, if you're using a log management tool, whether it's Splunk, Logstash, Logentries, and other solutions, you can use the software as the intelligence layer on top of these log management tools. So we're going to help you figure out what's the best way of streaming for you, and it's just several clicks away. We use syslog configuration. You can use our own agent. There are many ways of how you stream data into the software, and it's just the shipping part. After data was shipped successfully to the server, whether it's we work SaaS or on-prem. So the cool part begins. So actually, the system receives the data and starts pre-processing it automatically. So I want to show you an example of that first phase. If you recall from my previous slide, here's an example of Juniper NetScreen logs, and I want to show you how the system knows how to pre-process them. So that's the raw input sample that we received from Juniper. This is the log. This is where the domain where we live in. And on the left side, you see a breakdown of this log into more structured format. So the system knows how to structure the data by breaking it to list of key and value pairs. In addition, it also classifies each of the fields automatically. So it knows that that's the message, that's the host, that's the severity, that's the timestamp, and these are just properties to give you the context. But more importantly, the system also figures out how to apply the relevant measurement method. So for instance, every metric here can be counted as a meter, which you see here, meter, which means that you want the system to build a baseline based on the number of occurrences this value has over time. Or on the other hand, you might want to treat this metric as gauge, which tells the system that the numerical value has a meaning by itself. For instance, latency or memory consumption, the numbers have value, and you want to measure them in a different measurement method. Now, the system knows how to classify each of these metrics, but you can also change it manually to your own desired method. And of course, if there's a field, of course, it knows which fields are not interesting because they don't have an interesting behavior, so it marks them off the list, and they shouldn't be monitored. And if you, as a more advanced user, wants to have more advanced manipulations, you can use the JavaScript console here on the right side to custom the results, and it takes several seconds until you see the results. You don't have to wait. and it will be something very easy for you to handle if as DevOps engineers. So to sum up what you're seeing here, actually all the pre-processing that you have today, instead of the traditional method of doing it, where you would have to choose which metrics you would like to measure, set thresholds to different fields, and start monitoring them, our AI does it all for you. The next thing is the incident, and let's talk about the detection and the analysis phase, as we said before. So that's actually the main system screen. This is the event feed on the left side. This is the inbox of events as they are generated automatically by the software, right? They have, in the middle, you have the details of each incident. You have action buttons and feedback buttons at the top right side. We're going to talk about them in a second, and insights from the right area. Now, I want to focus on when we talked about the detection part, right? So we all using infrastructure monitoring tools, or just waiting for our users to complain. But we want to become more proactive. So the first thing you want to do is, the first analysis method that we talked before is actually looking for bad keywords, right? Looking for errors, fails, exceptions. And what you see here is an example of exactly that. So the system comes packed with all the bad keywords you can imagine, like bad, keyword, exception, fatal, error, and so on and so forth. And it continually monitors all of these bad keywords to see if something has changed. For instance, in this example, what you can see here is that your ESXi log has more failed keywords than usual. So you don't have to look for bad keywords anymore, and the system does that for you all the time. And if you do have something very unique, if you have a unique keyword you want to add to the list, it's just fine. So there's a place where you can add your keywords, and these keywords will be monitored continually by the software without ever getting tired, without having you to define what's the threshold for these keywords. And one of the things that's so important to emphasize here is, because we're using anomaly detection, and you can see the baseline, this is the green bar here, and you can see why we think there's an anomaly here and why we think it requires their attention. Using the anomaly detection alongside with the keywords analysis actually mimics the work of the detection and the identification phase that we just described. So that's our way of making sure that you're always on top of things, even without having you to define what's interesting to monitor. So that's for the first part. Let's talk about the other types of detection that we talked before. Let's talk about weird phenomena. And here in this case, I want to talk about, when we talked about textual shapes analysis and how can we detect things that look differently in the data. So what you're seeing here is an example of a Hadoop Hive pattern that appeared for the first time ever in the system and classified as a new behavior by the software. So the software tells you that this pattern, background retry, gave up, org, Apache, creator, and so on and so forth, appeared for the first time, and actually very interesting, and tells you that, hey guys, you should go and see what's going on here, because that's the first time I'm ever seeing it. So it's actually, in many aspects, it tells you that things look weird, right? Tells you about the weird phenomena. So we think that this is a great way for you to, it will make sure you're covered, even if you don't know which keywords are interesting. Or in some cases, if your logs are in foreign language, like we had in the past, working with one of the German companies or companies in Japan, we had logs in German or in Japanese. And the fact the system would be able to detect anomalies, even if it's not familiar with keywords, that would be something that we were really proud of that, because the way we do that is by also detecting these weird phenomena in the data. So that's the second part of anomaly, which I want to show you. Moving forward with the analysis phase, we talked about correlations, right? So let's see an example of a more advanced use case. This example is from e-commerce web application, which is deployed within 8 Tomcat web servers behind the HA proxy, which acts as a load balancer. So during routine times, the load balancer routes the traffic evenly between these 8 servers, but because of an issue, a configuration issue in the HA proxy, the traffic was routed into 2 servers instead of 8. now you have problems coming all across your stack. And the cool thing about the correlation engine is here you see an example of all these issues as they're reflected in the software. And there are different anomalies here that are occurring simultaneously. So the HA proxy tells you that you have an anomaly in the error found in configuration file. This appears more than usual. That's the spike we believe is important. And on the same time, the overall number of error messages was increasing. And the application layer tell you that user transactions cannot be completed. This is where you're losing money, by the way, right? Because transactions can't be completed. And the Apache Tomcat web server tell you the connection pool is full, discarding connections, and so on and so forth. So what we found out many times, especially in complex environments, is that whenever these issues occur, we have what we call the circle of blame, where the application team thinks, no, it's the infrastructure guys, and they say, no, it's the network, and maybe these guys think it's the integration team. So you have, and maybe one of the teams is in India, and the other team is the States, so you have a problem of finding what is the problem. And just by correlating everything as one holistic incident, the system gives you the context you need to better understand what you have to do about it. And it also helps you reduce the alerts and not giving you 4 different alerts, because then you're going to have an alert fatigue, which is a different problem. By correlating, you actually have everything you need in one place. And the way we do this correlation is very important to emphasize, because it's based on time, of course, because this is what humans are doing when they triage issues, but also by looking for similarity of entities. So every time the software finds something, it finds a problematic log line, it extracts the entities that it thinks that are interesting. For instance, IP address or users or path. These are extracted by the software, and then it goes and takes this entity and fetch other logs that share the same entity and was anomalous during the same time window. So it's exactly the way that human beings are doing. The software mimics the work of these engineers and bring together all the anomalies in one place to give you everything you need in the same incident. So that's another example of the analysis phase. And also, speaking of root cause and root cause analysis, every time you click on a specific anomaly like here, the system pinpoints the relevant properties that might be accountable for the anomaly. So in this case, we can see that these 2 servers are the ones that changed the most during this time window. So instead of you trying to figure out what the hell is going on here and what has changed during this anomalous time window, the system scans all the properties, because it's a robot and it can do that all across your stack. And it goes and tell you, hey guys, these 2 hosts are the ones that changed mostly during this time, and go and figure out what's going on around there. This is where actually the system thinks is the root cause of the issue. So that's one of the cool features. We call it significant change analysis. And last, for the research part that we talked before, instead of you trying to figure out, I think that this example of the ESXi is actually more interesting. When the system triggers an event, like in the ESXi example, where you have the overall number of failed was increasing significantly, so the system tells you, hey guys, not only that the overall number of failed message was increasing, but also these are the log lines that contain these failed keywords. And it brings together all the log lines that contain that. Now, there are 2 options, if you recall from the previous slide. Either you know what that log line means, fetch vsi, model name, port config, and so on and so forth, or you don't know what these means, like I don't know. And instead of you going to Google and search for that result, the results here are enriched on the right side with an insight and a recommendation. So if you look on the right side, you see Sophie. She's our AI team member, and she speaks to you and actually explains to you what's happening here. And she tells you there's a known bug here on ESXi host, which configured to use a VDS. And if you add a new virtual adapter to the VDS, the syslog file might log this error message. So we also recommend about the relevant course of action that you should take. And it tells you that this can be resolved by applying this knowledge base. So instead of you be dependent on the tribal knowledge that you have in the organization, or instead of you going and Google the result, the software comes with insights around these issues. We call it tribal knowledge base. And the way we do these insights is by having a hybrid approach. First, we have a team of data scientists that keep any insights around generic technologies that everyone are using. So all the third parties, right? So we took the 80% of common technologies like web servers and databases and Active Directory and network equipment, the technologies that everyone are using, and in fact, these are the modern building blocks of today's infrastructure. Most of these issues are already enriched with insights based on our team, so you can have value out of the box. However, and that's the cool part, if you do have your own homegrown app, so of course, we're not familiar with your logs, right? So how can we help you with the insights? So for this, we use the power of the crowd. So the wisdom of the crowd, sorry. So every time you're as an engineer, let's say I'm a NOC operator, and I woke you up in the middle of the night to resolve an issue. So you come and you fix it, and you find out that that was actually a configuration issue. So you click on the done button here on the top right side, and the software will ask you two straightforward questions. What's the problem, and how would you solve it? Now, it will recommend about previous resolutions for that issue, like you see here, or it will allow you to add your own one to the list. Once you're adding your own insight, the software learns from your experience and saves it in the organization for future reference. So over time, you're actually building a body of knowledge which is ever growing and is integrated into the workflow of the user. Because nobody, including ourselves, likes to document the knowledge, right? Knowledge management is very hard to do. So just by doing that and keep annotating logs with their meanings, you're building here a body of knowledge internally in the organization. And we use the same accumulated knowledge from all of our customers as a crowdsource engine, and we cleaning it and make sure that it's moderated and redistributed to all of our customers. So in fact, you're enjoying the world's largest logs and the resolutions database, and it's all updated in real time. So last thing I want to show you, and it's more about the machine learning part and where there's all sorts of concepts that we added to the software to allow the robot grow and get better, is the feedback buttons, right? So there's no machine learning can learn without a feedback loop. So this is why we have these types of feedback. So for instance, let's say you got this alert from the software and it tells you that this message appears, but you see that message and you say, all right, I'm not interested in getting these log lines, these alerts. It's not this log line is not interesting. So you can click on the mute button and it will ask you if you want to mute it temporarily or forever. Muting something forever will calibrate the system and will tell them that you don't want to get alerts based on these log lines. And this is a great feedback, and over time, you will only be alerted about the issues that require your attention and you're interested in. You won't be alerted on things that you don't really care, which is the end result, right? So instead of, so that's one kind of feedback. The other type of feedback is more of the sensitivity part, is the raise button. The raise button is actually tells the system to be less sensitive in its automated thresholds. So let's say you want to get notified about these failures, but only if they're much more, if their volume is higher. So you want the system to be less sensitive. So clicking on the raise button will recalibrate its mechanism to tell you only on things that are much more with a higher volume rate. So as you can see here, what we're trying to do, we're trying to achieve, instead of going to the machine learning, supervised learning approach, where you have to train the system and only then you can start seeing the value, we actually took the other approach of providing you value after connecting your data set, and this value will continue to, and providing you value from the first 90 minutes. And over time, learning the way you use the software and learning from your feedback about what's interesting and what's not. So in many aspects, you nurture a robot analyst, which is going to be your new best friend, and we're going to help you and to be much more empowered and will allow you to focus on other important ID matters that everyone has. So you'll be more proactive. You'll be able to reduce the time to resolution by almost twice as fast as you do today. And these are two really important KPIs that our customers are seeing after about 1 month of using our software. So I'm going to do a hard stop here, and with that in mind, I want to go back to the slide and wrap up this live demonstration and this part of the webinar. So I'm going to reshare my screen with you guys. So going back to the deck, and thank you for being patient, we talked about, here's a quick recap of the capabilities we've just shown you. First is the ability to pre-process the data automatically, right? We talked about the analysis phase, searching for every type of bad keyword automatically. We talked about using anomaly detection to detect issues in the production environment. We talked about analysis, the different types of analysis, like looking for weird phenomena in the data or correlating issues all across your stack from different components. We talked about analysis and how can the system help you isolate the root cause by showing you significant changes. And we talked about insights and recommendation, which help you with the research phase, which is very, very important. So the system will tell you that something is not working. It will help you figure out what's the root cause of that. And really, the only thing that's left is to really go and fix that issue, whether you have an automation tool or doing it manually. So I'd like at this stage to summarize the root cause analysis process and before and after applying AI, and talk about the differences that we just described. So before AI, you have to define what to monitor, and after using AI, you have the measure all approach that actually everything has been measured all the time, providing you with a never getting tired solution, which will tell you also about the unknowns. The other part is that with human analysts, we need to prepare the data for analysis. We need to parse and configure it. And in AI, you can use automated pre-processing like parsing and classification of the data. Without AI, you need to search for issues, and your approach is reactive, just as your poll is describing. And with AI, you can use anomaly detection to become proactive about your customer's problems. As a human analyst, you need to analyze and correlate everything manually, which is a very difficult thing to do. And with robot analysts, you can use the automated root cause analysis algorithm. Before AI, you need to seek solutions by researching the internet or asking your colleagues and tribal knowledge. And with the AI, you can use insights from an ever-growing knowledge base and to have them documented into the organization. And last but not least, and this is something only machines can do, I think, machines are built for scale. And true scale is almost impossible to do with humans only. So we have to use machines to fight machines, just like in Matrix, right? And that's exactly where AI can help us. And I think that sums up all the advantages of using it today, how to apply AI in today's root cause analysis process. So guys, thank you so much for listening up until now. And we really encourage you to take us for a ride. Don't take us for granted. And if you're interested in a free trial, just drop me a note or visit our website. There's always someone there, and we can take it from there. And so I'm going to have some time for questions and answers. I want to thank you again, and let's move with the Q&A session.
Excellent, excellent. Thank you, Dror, so much. We have gotten so many great questions in so far. I don't know we're going to be able to get to all of them today, but please know that if we can't get to all of everybody's questions, that you guys definitely will be following up with the audience members who do submit questions. So fret not, your question will be answered whether right now or post-webinar. So let's go ahead and get to them. The first one is from Yitz, who's asking, do I need to prepare the data before I ship it to the system?
Got it. Thanks for the question. So, by means of preparing the data, the answer is no. The only thing you have to do is to ship the data into the software by using whether our agent or configuring rsyslog or even uploading a file to S3 folder or whatever you want to upload it by a secure FTP server we take log lines, whether it's log file, textual files, CSVs, all types of these, all these structures are supported by the software. In fact, we support every type of semi-structured log line or metric. So any type of textual input, as long as it is machine-generated input. We won't analyze emails, right? We're going to analyze machine-generated input, and you don't need to prepare the data.
Awesome. Great. Next question is from Shay, who's asking, what is your experience with big enterprises, especially ones with huge internal code base?
So thanks for this. To be honest, our main target audience is medium and large enterprises because they really appreciate, and first of all, they really have complex IT environments, right? So usually sometimes they have a hybrid environment, sometimes everything is on-prem, and they have so many servers, so many virtualization components, sometimes microservices, and this is exactly what we're doing. So we're working with the largest financial institutions you can imagine, one of the largest consumer good companies in the US, a large media company, financial institutions in Australia, in Europe. This is kind of the things that we usually do. We go to the big enterprise, we focus on specific use cases that they want to solve, we show them the value after a quick evaluation period, and then we discuss what's the best way to implement our solution all across the stack.
Great. So I imagine you have a lot of experience then with large enterprises. That's great. Okay, next question.
Charlene, sorry for interrupting. Maybe I want to say something about scale because I think it's important. Maybe the question was around scale, so I'd like to address that as well. Yep. The way that the system was designed from the ground up to support vast amounts of data. So the way we do this is by actually transforming all your log lines into metrics and analyzing them as time series rather than on logs. So it's a very efficient solution. We have installations with one of the customers have around 1,000 servers, and we use one Loom instance to analyze everything. So because the computing is being done in real time instead of the log lines, we are able to be very efficient in the computing part and to support problems of large organizations who have so many logs streaming in their environments. So sorry for interjecting. I think it's important to say.
No, that's totally cool. Thanks. Okay, so the next question is, let's see. The question is, how does Loom know to correlate the 4 issues into a single alert? Does it link by timestamp and behavior, or could it back end into something like a CMDB where it sees commonality in a component, which in turn can aid resolution?
Great question. So I like to let me further explain the way the correlation engine works. So first, anomalies are being detected, right, by the software. Now, after these are detected by the software looks on time as the organizing factor, as you said. But also, and this is something that we introduced in Loom 2.0, which we introduced around 2 months ago, we're also doing, as I said before, semantic analysis on the log line. So let's say they contain an entity of interest, like an IP address or user or any kind of correlator tag, like an ID of some kind. So the system extracts these IDs or entities and fetch other logs that contain the same entity. So that hybrid approach of using time or using the metadata and the data is what the correlation is based upon. However, in terms of looking forward, in terms of the roadmap, one of the things that we're also working now is integrating with other CMDB tools to have better service discovery and also have some impact analysis about the exact components that are suffering now. So this is something that's definitely on our roadmap. Today, we do not use the CMDBs in order to correlate.
All right, great. Next question is from Hugh, who asks, how do you update the KB and keep it up to date? Cool.
So knowledge base, the insights part, the tribal knowledge base of our solution has two, we use, as I said before, a hybrid approach for that. First, we have a team of data scientists that keep adding insights themselves. So you can have to support all your third-party applications and make sure that you have the right insight around these third parties. But also, you as a user, when you add these insights, we moderate these insights and make sure that you don't have any sensitive information and make sure there's no garbage there. And then we redistribute it to all of our customers. So you can use it as an internal documentation tool, and you as a user can add insights. You can enjoy from the insights that are already there and keep being updated on a daily basis. And this is the way it's been done today. So both crowd wisdom and also tribal knowledge all documented in one place and being moderated.
All right, great. Doing a quick time check here. We're about 5 minutes before the top of the hour, so I think we can do 1 or 2 more questions. We actually have a comment. APM tools have been avoiding root cause analysis for years. Any idea why that's happening?
I think, it's a good question. We are actually talking with all sorts of APM vendors. Some of them start to understand the options that are in the logs. They neglected the logs domain for many years. They used to do it instrumentation, which is a great way of doing some root cause analysis in terms of the application itself, but they don't treat the environment. They can't see the environment which is not instrumented. So let's say you have a problem in your application, but it's actually the network is what's affecting it, or your APIs is what's affecting it. So they won't have this visibility. So I think we see some players now going in that direction, which is great. To be honest, most of our customers today already have some APM in place. They also have some log management tool in place, but they still want to use Loom. So for instance, they say, I'm paying X million dollars for Splunk, for instance, but I'm having a hard time to capture the value using this solution. So can you help me amplify my Splunk usage with intelligence? Which is great, and we love to work with these customers. We love to work alongside Splunk, and we love to work with customers that don't have any log management tool in place or don't have any APM. So our software actually goes well with the APM tool, goes well with a log management tool, or goes well with if you don't have any of these tools in your stack.
Okay, great. Next question: are there unmute and lower options for recalibrating the system back to earlier set?
Can you repeat the question, Charlene? I'm afraid
Sure.
I didn't hear.
Yeah, no problem. Are there unmute and lower options for recalibrating a system back to earlier set? So it sounds like, can you roll back changes? Yeah.
Yeah, great. Yeah, great question. This is one of the things that we developed along the time when we started work with large enterprises, and they have these huge amount of features that they want us to develop. So definitely yes. There's always a place where you can go back and see which of the patterns did you mute and which of the patterns did you raise, and you can go back and unmute them or unraise them. And of course, you can see also what other users have done. There's an activity log, and if someone deleted an incident, you can revive it and use it again and again.
Excellent. Excellent. Well, I think that is pretty much all about all the time that we have for the questions. I would like to thank Dror Mann for being such a great presenter today. It was a fascinating presentation. As you can see on the screen, Dror is sharing his email address, so if any of the audience has any questions for Dror, would like to follow up with the information, I'm sure he or any of the Loom Systems folks would be happy to help you out. Please be sure to check the DevOps.com website for upcoming webinars, and also, like as I said before, check out the DevOps.com website for replays of this webinar starting probably this time tomorrow. But right now, it leaves it for me again to thank Dror for joining me today. This is Charlene O'Hanlon at DevOps.com, and thank you for joining us.
Thank you so much, guys. Thank you, DevOps.com, and thank you for all the listeners. See you next time.